In this problem, we have permutations with identical objects. That meaning that we have 11 different flowers, 5 are going to be white, and then the remaining ones are all red. So the formula for this is a little bit different if you have identical objects. The formula is n factorial over r1 factorial, r2 factorial, r3 factorial, up to rk factorial. And let's talk about that. N factorial, again, just like the last one, is how many objects do I have to choose from. So in this particular problem, I have 11 objects, so I have 11 factorial. In the denominator, I'm going to put identical objects. So like I have, let's write it out here, we have white, I have 5 of them, they're identical, they're all white. And red, if I have 5 white ones and all the remaining ones are red, that means I'm going to have 6 red. So in the denominator, I'm going to have 5 factorial, and I'm going to have 6 factorial. So in order to do this problem, I'm going to write out, to simplify, I have 11 factorial, which is 11 times 10 times 9 times 8 times 7 times 6, and I'm going to put 6 factorial because that's 6 times 5 times 4 times 3 times 2 times 1, which is the same thing I have right here with this 6 factorial. So I have 5 factorial times 6 factorial. Since I have the 6 factorial on the top and the bottom, denominator and numerator, I can cancel out the 6 factorials. And I'm left with 11 times 10 times 9 times 8 times 7 in the numerator. I have 5 times 4 times 3 times 2 times 1 in the denominator. So to cancel stuff out now, so let's look at 10. 10 is the same as 5 times 2. 5 times 2 is 10, so I'm going to cancel out the 10 and the 5 and the 2. I don't think I can do that with anything else. So that's simplified as far as I can simplify it. So I have 11 times 9 times 8 times 7 in the numerator. So I have 11 times 9 times 8 times 7, which will give me 5,544 over 4 times 3 times 1 is 12. And then I'm going to divide 5,544 divided by 12. And that gives me 462. So I have 462 ways that I could plant these 11 different flowers.